Today we are going to focus on another metric which will help you to analyze the profitability of your investment, which is called internal rate of return. And we'll also introduce two other rules for investment decisions based on internal rate of return. Strictly speaking, if you look at any textbook, the meaning, the definition, the classic definition of internal rate of return is the discount rate which makes the net present value of an investment equals to zero. The actual meaning, the actual idea of internal rate of return is annualized rate of return which you are actually earning on your investment. So how much in the percentage terms you are actually making when you've purchased a particular asset. It's not very intuitive, but let's have a look at the example and it will become easier. Let's have a look at our property. The same house, buy it at £500, keep for 3 years, then resell at the end of 3 years, and our return used to be 7% in alternative investment. But how much return are we actually getting if we are investing in this particular property? Let's calculate. This is the table which we've had already, the table with our cash flows. So we can see the actual purchase price, cash flow in year 0. Then there are no cash flows in year 1 and year 2. And then at the end of year 3, we sell the property and receive our sale price, $685,000. Previously, we've written down the formula for net present value. So we move all our cash flows into the formula. So for example, minus £500 in year 0, then 0 in year 1 and year 2, and then there will be some positive cash flow at the end of year 3. This is the formula which we've had for net present value. But now, instead of having 7% as our discount rate, we simply replace this with some unknown internal rate of return, which we'll try to calculate. We equalize net present value to 0, and then we have an equation with one unknown, which we can then solve. Strictly speaking, you can solve this mathematically, but you don't have to, because there is a formula for this in Excel, in Microsoft Excel. So you simply create this table in Excel, write down, type the formula, and it will calculate it for you. So it will be very easy, super easy formula. So this slide shows a screenshot from Excel spreadsheet, same table showing cash flows. We've calculated present value of cash inflows, present value of cash outflows using previous formula, using 7% as a discount rate. And this is the number, £59,000 for net present value, which we've calculated previously. In order to calculate internal rate of return, so this is what we have here shown in blue, we type the formula IRR, and we actually add all cash flows starting from year 0, cells C5 to F5, and it will generate a number for us. So we can see here that the actual return in percentage terms for this project is 11.06%. Our alternative investment will only generate 7% return. But this particular project will generate 11% return, which is obviously much better. And that is why net present value is positive. It will make us richer compared to alternative investment. When we use this formula in Excel, it's very important to specify all cash flows. So even cash flow in year 1 and year 2, when we don't pay, we don't receive any payments, we need to add zeros here. Otherwise, the formula will not work properly. If you don't expect to receive any payments in a particular year, don't skip this year. You need to specify cash flow in every single year to ensure that the numbers will be calculated correctly. Type zeros if you don't get any cash flows in a particular period. Interestingly enough, if we deposited £500,000 at this interest rate at 11%, we would end up with the same sum, £685,000 in 3 years. So our cash flow at the end of year 3 is 685, and this is what we've got after we've invested 500,000. In order to get this sum, in order to get to this amount of money, we need to invest our money at 11%. Let's introduce decision-making rule 3. You should only undertake a project if the internal rate of return from this particular project exceeds your discount rate. So your discount rate is the rate of return from alternative investment, for example, 7%. This is what you would get if you invested your money in a savings account, for example, or in some other project, or in a stock market, 7%. You should only invest in property if the internal rate of return from this particular property is higher than 7%. Generally, what is important here is that your discount rate, your base for comparison, will be different for different investor. It depends on what else, what you can get, what is your next best alternative. It depends on your specific circumstances. It depends on your access to alternative investment. Only buy a property if it generates at least this amount or preferably more, if it exceeds your discount rate. A few more examples to illustrate it, to make it easier to understand. So we buy the same property, £500,000, but we expect to sell it at a lower amount. So in this case, in 3 years' time, we only hope to get 575,000 for it, not 600 plus, which we've had in the previous example. Our return from alternative investment is still 7%. The question is, what is the internal rate of return from this particular house now, and should we buy it or not? Let's have a look how our analysis will now change. The same table in Excel, the same cash flows apart from one. Our cash flow at the end of year 3 is now lower. It's 575,000 rather than 685. The formula for internal rate of return is the same as before, but the numbers are now different, and we can see here that in this case, this particular property will only generate internal rate of return equal to 4.77%, less than 5%, while our discount rate is 7%. We are better off simply putting our money in alternative investment, for example, a bank account. We should not buy this property. And what you can also see is that net present value in this case becomes negative. Net present value was calculated as minus £30,000. So if we'd purchase this house in today's terms, it would make us poorer by 30,000. We would lose £30,000 in today's terms. Yes, in numeric terms, we would get some profit, £75,000 profit from reselling this property, but we would be better off by investing money elsewhere. Our return would be better. Compared to alternative investment, we are losing £30,000. That is why we should not invest. We should simply go for alternative investment. This table actually illustrates this idea. It allows us to compare two alternatives. So first part, top part of the table shows our property. It shows that we are able to get 575,000 at the end of year 3, and internal rate of return is 4.77%. However, if we invest the same amount of money, £500,000, at a bank account, which generates 7% return, at the end of the same period, year 3, we would have a larger sum of money. We would have £612,000 rather than 575. We are better off with a bank account, and these numbers shown in blue here demonstrate the difference in different projects. So this particular property is not as good compared to the bank account. We should not go for it. When we have a choice between two projects, apparently we should invest in a project which generates highest return. And in this case, it's a bank account with a return of 7% rather than 4.77%. So this is an example of how we can use internal rate of return rule for investment decisions. And again, this table allows us to reach the same conclusion based on net present value. We know that we should only invest when net present value of a project is positive. In this particular case, it's negative. It's minus £30,000. We are worse off, and we should not invest. We are paying £500,000 for a stream of income, which in today's terms is only worth £469,000. We should not invest. We are overpaying for this property based on the expected future cash flows which it will generate. Investors should look at these metrics, net present value and internal rate of returns. And in this particular scenario, both metrics, both decision-making rules tell us that we should not invest. Net present value is negative, therefore we should not invest. Internal rate of return is lower than our discount rate, therefore we should not invest. However, it will not always be the case when two different types of performance measures will give us the same advice. Sometimes they will contradict each other, and we'll need to understand how to make a decision in that scenarios. Let's have a look at some other examples. Let's recall our comparison between two properties, two alternatives. For example, the house and the flat. So our first project, our initial property, we spent £500,000, resell in 3 years, received resale price 685, and net present value of this project is 59,000. Or alternatively, we can buy a flat, buy a lower price, 230, resell in 3 years. And apart from this, we also get £24,000 annual rent. And we've calculated that net present value of this project will be £45,000. So we can see here that based on net present value rule, we should invest into investment project 1 because net present value is higher. It will make us richer. Now, let's calculate internal rate of return. Set up the same tables as before, same layout. So you can actually, I recommend that you stop the slideshow now and have a look at these tables, at these spreadsheets, analyze them, look at the numbers to see what is going on here. Generally, these two tables show cash flows for both projects. So these numbers in blue show net present value for each project, 59 and 45,000 pounds. And both tables also demonstrate internal rates of return. And what you can see here is that internal rate of return for the house for project 1 is 11%, while internal rate of return for the flat is more than 14%. So house seems to be more profitable from net present value point of view. However, a flat generates high return in percentages, in percentage terms. So the question is, both projects are profitable, we can see it, but which project should we choose then? If we can only afford to buy one property, what should we do? Should we pay more attention to net present value or internal rate of return? So what would you do here? Just think carefully, look at the tables, and let's move on to the next slide. Generally, what is important is that net present value is much more important in this case. When you buy a flat, you do generate higher percentage returns, but you receive your 14% return on a smaller sum. And as a result, your actual increase in wealth will be lower, 40,000 rather than 59. So generally, you undertake a project if its internal rate of return is greater than your discount rate, unless there is another project with much higher net present value. Net present value shows how much wealthier you will become as a result of this investment project. Doesn't really matter what internal rate of return, even if it's lower, as long as it's higher than your discount rate, go for the project with a high net present value. So generally, if we compare this house and the flat, go for a house because net present value is higher, in spite of the fact that internal rate of return is only 11% compared to the flat, which generates 14%. Or if you're lucky enough, you can buy both if you can have enough money, because both are fantastic investment opportunities. So this is a summary. This table shows a summary of all decision-making rules which we can specify based on net present value and internal rate of returns. So these are two metrics which demonstrate performance of investment projects, quite important variables, which we need to calculate for any potential investment. And generally, these are the rules which you should follow.